Hello, students. Welcome back to NEET Masterclass Physics with Sparkl. So, today I have come up with the topics nuclei, atoms, and semiconductors. These are very easy topics. Generally, questions asked in them are purely from NCRT. Only you have to learn and remember the formulas. That's it. There is a very limited variety of questions in these chapters. So, let's start quickly with the questions. Uh, First question: in the figure given, voltage of point A is. So it is clearly uh, visible through the figure that you have been asked if the diode is forward or reverse bias. So this is the P side and this is the N side, and N side is earth, then P side is at minus 3 volt. So this diode is reverse biased. When this diode is reverse biased, the current is zero. So if the potential here is zero, the potential at A will also be 0 volt. So easy question. You just have to identify if the diode is forward or reverse bias. Statement 1: by doping silicon with pentavalent material, the electron density increases. Okay, that's correct. Statement 2: the N type semiconductor has a net negative charge. No, semiconductors either P type or N type, they are electrically neutral. So the second statement is incorrect. So our option will be 1 is true and 2 is false. In the logic circuit shown in the figure, if the input at A and B are 0 and 1 respectively, the output at Y is. So again, in semiconductors, if you see the topics that you must know is the logic gates. One question will come from the logic gates, one question will come from the diode part, the reverse or forward bias, or the application of diodes. So there will be two questions. All right. Similarly, from atom and nuclei, there can be one question from each of the chapter. They are very small chapters, and generally question which has been already asked, a similar kind of question or from NCRT it is asked. So you have to prepare these chapters very wisely, and entire modern physics and semiconductor, it's very scoring, and it's very easy, and around 7 8 questions will be asked from these topics, so you shouldn't miss even a single question. All right. So yeah, when 0 is given at A and 1 is given at B, so let's see what it becomes. So 0 here, now it is passed through NOT gate, so this is 1 over here and 0 over here. Here it will be 0 and 1, and its opposite, here it will be 0. Now what kind of gate is it? So it's a NOR gate. Okay, and it's a NAND gate. So if 0 and 0 will be given to a NOR gate, all right, the output will be 1. If 1 and 0 is given to a AND gate, the output will be 0. If it is NAND, it will be 1 only. Okay, and 0 and 0, it's OR. So OR is 0 and it's NOR, so it's 1. And 1 on 1 is given to a AND gate, so the answer will be 1. All right, next question. Again, a logic gate question. The output of the given logic circuit is, so here we have A, here we have A, here we have A, and here we have B, and the output of this will be this a NAND gate, so it will be A dot B bar. All right, and here it will be A bar dot B and A dot B bar. So it's again a NAND gate, and this is an OR gate. Okay, so the output here will be A dot AB bar to the whole bar. All right, and here the output will be A dot B bar, and here it is B plus B, and the output to all these things here will be the NAND of these two. So it's a NAND gate again. All right. Next question. If an electron in a hydrogen atom jumps from fourth orbit to third orbit, it emits a photon of wavelength lambda. All right. So, and when it jumps from third to the second orbit, the corresponding wavelength of the photon is. So, we know that 1 by lambda is proportional to 1 upon n1 square minus 1 upon n2 square. All right. So, let's put up the values. So, 1 upon lambda will be equal to jumps from fourth orbit to the third orbit. So, this will be 1 upon 3 square minus 1 upon 4 square upon 1 upon lambda dash will be third to the second orbit. So 1 upon 2 square minus 1 upon 3 square. All right. So from here, we'll say lambda dash upon lambda will become, we take the LCM over here. So it will be 9, 1 by 9, or we just simply write it 1 by 9 minus 1 by 16 upon, it will be 1 by 4 minus 1 upon 9. तो इसको अब सॉल्व करेंगे अगर हम, तो it will come out to be this is 16 minus 9 into upon 16 into 9 upon 9 minus 4 into upon 9 into 4. So lambda dash upon lambda will become, this will be 7 upon 16 into 9 upon 5 upon 9 into 4. 9 and 9 gets cancelled and this becomes 4 times, so it becomes 7 upon 20. So our answer will be 7 lambda upon 20. So this is what we have to do. We have to remember this formula and do the calculations a little carefully. That's it. And in an intrinsic semiconductor, the intrinsic carrier concentration is 2 into 10 to the power 19. On doping with boron, the whole concentration becomes 4 into 10 to the power 22. So NH is equal to 4 into 10 to the power 22. Ni is 2 into 10 to the power 19. So see that Ne into Nh will be equal to Ni square. We just put the values, we have to find the Ne electron concentration. So Ne will be equal to Ni 4 into 10 to the power 38. I squared it upon 4 into 10 to the power 22. So it will become, Ne will become, this will become 10 to the power 16. All right. 1 into 10 to the power 16. So this will be my answer. The net charge on a p-type semiconductor and n-type semiconductor is respectively. So they are electrically neutral. All right. You don't have to see the sign. They are electrically neutral. What is the reading of ideal emitters A1 and A2 connected in the circuit diagram if p-n junction diodes are ideal? So we have to find the reading of emitter. So again we have to identify key which one will be reverse biased or which one will be forward biased. So we can see that this D1 diode, D1 will be reverse biased because if I take like uh, a lower potential, it will have a lower potential over here and higher potential over here, and D2 will be forward biased. Okay, so the current will flow like this. So current through diode D1 uh, will be 0, and due to D2 it will be 18 upon the total resistance is 9, so it will be 2 ampere. Okay, so 2 ampere and 0, 0 and 2 ampere. Yeah. Next question. What is the equivalent resistance across the terminals of the battery if diodes are ideal? Okay, so we have to find the basically the equivalent resistance. Here also we have to identify the same thing, ki which one is forward biased and which one is reverse biased. So if you see, so this one will be forward biased and this one will be reverse biased. So no current will flow from over here So this circuit will be there, and the R equivalent will be 20 ohms. If a PN junction is reverse bias, then diffusion current decreases. Yes, diffusion current will decrease. Drift current will remain the same. Net current within the diode flows from N side to P side. Yeah, that's correct. So all of the above are correct. The diagram shows the energy level for an electron in certain hydrogen-like atom in which transition the wavelength of emitted electron is minimum. So lambda will be proportional to delta E. So whichever transition has the maximum uh, energy difference will have the minimum energy or minimum wavelength of the photon emitted. So let's see. Let's consider it hydrogen atom only. So this will be minus of 13.6. It will be minus of point 3.4, minus 1.51, and minus of 0.85. So if we see the difference, like which will have the maximum energy difference, so maximum energy difference will be from here to here in the first one. Okay. This one will be the maximum energy difference, so maximum energy difference will be in the one, so this will be our answer. All right, next question. Magnetic moment of a atom having atomic number z in n minus 1 the excited state, मतलब कि nth n is equal to n हो गया if this is the case. So magnetic dipole moment निकालना है हमें. So we know that m by l is equal to q upon 2m. So m is proportional to l. Now l angular momentum is nh upon 2 pi. So it is proportional to n. Yes, so magnetic moment will be proportional to n over here. If potential energy of an electron is chosen to be zero in the first orbit of hydrogen atom, then the total energy of the electron. So let's see how is it. ये बहुत इंपॉर्टेंट क्वेश्चन है. ऐसे क्वेश्चंस पूछे गए हैं पहले भी. So the total energy over here is minus of 13.6, minus of 3.4, and the potential energy is twice of the total energy. So it is minus of it will become 27.2, minus of 27.2. It will become minus of 6.8 over here, whatever. So see, what we have to do is we are told that potential energy over here in the ground state is taken to be zero. So everything, like everything should be added with how much? 27.2, right? Every should, because we have increased the potential energy over here by 27.2. So everything should be increased by 27.2. So the total energy in second orbit will be minus 3.4 plus 27.2. So it will come out to be 23.8 electron volt. All right. So this will be my answer. The orbital speed of He plus atom in a hydrogen in the ground state is, so speed is c upon 137 into z upon n. Okay. So ground state is given, and z is equal to 2 over here. So we just put the values to 2c upon 137 will be the answer. So you have to remember these formulas. That's it. That's what you have to do in this chapters. All right. If a naught is the Bohr's radius of hydrogen atom in ground state, the orbital radius of H-like ions is. Okay. So R, this general formula R naught into n square upon Z. So that's what we'll do. R naught की जगह यहाँ पर A naught दिया हुआ है. So this will be our answer. So again a direct formula, but it is important. So मैंने ये question include किया, and you have to remember this formula because many questions can be asked on this particular formula. Okay. If the total energy, sorry, T, K, and U represent the total energy, kinetic energy, and potential energy of an electron in given orbit, तो हमें पता होता है कि total energy जो होता है वो पोटेंशियल एनर्जी का हाफ होता है, एंड जो टोटल एनर्जी है उसका मैग्नीट्यूड जो है वो काइनेटिक एनर्जी के बराबर होता है। ठीक है, सो U will be equal to 2 times of T. That will be our option. Okay, ये क्यों नहीं होगा? बिकॉज ये मैग्नीट्यूड होता है, टोटल एनर्जी का मैग्नीट्यूड इज इक्वल टू द काइनेटिक एनर्जी का मैग्नीट्यूड। ऑलराइट, द पोटेंशियल एनर्जी ऑफ इलेक्ट्रॉन इन हाइड्रोजन एटम in an excited state is 1.088 electron volt. The um, photon, the energy of photon emitted when it electron makes a transition to first excited state. So okay, so let's see. Potential energy is 1.088. So if potential energy is 1.088, the total energy will become 0.544 electron volts. All right, and the energy in the nth orbit is minus of 13.6 upon n square. So let's equate it to 0.544. So if we solve it, the value of n comes out to be 5. So from here, the energy of the value of n will come out to be 5. Now, the energy of photon emitted when electron makes a transition to first excited state. So n is equal to 2. So हमें n is equal to 5 से कहाँ ले जाना है? n is equal to 2 में ले जाना है। ठीक है, सो द हमें एनर्जी ऑफ फोटोन उसमें चाहिए। तो उस केस में जो एनर्जी हो जाएगा वो कितना हो जाएगा? दिस विल बिकम माइनस 13.6 इंटू 1/2 स्क्वायर माइनस 1/5 स्क्वायर। So if we solve it, it will be minus 13.6 into this will be 1 by 4 minus 1 upon 25, and इसको हम सॉल्व करेंगे तो it will get 13.6 into 21 upon 100. So it will be 13.6 into 21 upon 100, and this thing it comes out to be 2.856 electron volts if you solve it. ठीक है, तो अगेन इट्स अ प्योरली फॉर्मूला बेस्ड क्वेश्चंस। बस यहाँ पे थोड़ा सा ट्रिक है कि दे हैव गिवन यू की हाइड्रोजन एटम में पोटेंशियल एनर्जी दिया है, तो हमें टोटल एनर्जी से फॉर्मूला सारे पता होते हैं। ऑलराइट, नेक्स्ट क्वेश्चन। The shortest wavelength of Balmer series to that of the longest wavelength of the Paschen series. Such kind of questions are also very important. So we know that for the Balmer series, the shortest wavelength it will be n infinity से from n will be मतलब transition होगा infinity to n is equal to 2, n is equal to infinity to n is equal to 2, and the longest wavelength of the Paschen series, the longest wavelength of the Paschen series will be from n is equal to 4 to n is equal to 3. All right, so this is what we have to do. So let's do it. So it will be 1 upon lambda Balmer is equal to r into, we can use that formula, 1 upon uh, infinity square minus 1 upon 2 square. Okay, now again 1 upon p will become r into 1 upon 4 square minus 1 upon 3 square. I could have written it as 1 upon 2 minus infinity or whatever. You get the same answer. So lambda p upon lambda b will come out to be, so this thing will become 1 upon 4, and this thing will become 1 by 16 and 9. So it will be uh, 16 into 9, and here it will be 7. Okay, so it will be lambda Paschen upon lambda Balmer will come out to be 16 into 9 upon 4 into 7. So it will be 36 upon 7, and we have to find Balmer upon Paschen. So this will be my answer. So such questions are also important. You just have to go through the series की कौन से series में which will be the shortest and which will be the longest wavelength. All right. Next question. Again, a simple question and an important question on nuclear radius. If the nuclear radius of aluminum is 3.6 Fermi, the approximate nuclear radius of Cu64 copper is, ठीक है? तो हमें पता है कि R1/R2 is equal to A1/A2 to the power 1 by 3. So R1/R2 will be 27/64 to the power 1 by 3. Now we are given the value of R1 3.6 and R2, and this will be, if you take the cube root, it will become 3 by 4. So it will be 1.2, and R2 will come out to be 4.8. Okay. So this will be my answer. So again, this is very important. You have to do it in the form of ratios, and ये formula हमें याद रखना है. Two nuclei have their masses in the ratio 1:3. Nuclear densities again है very important. हर nucleus की density same होती है, like nuclear density is constant, so ratio is 1:1. आपको ये ध्यान रखना है. Next, in any fission process, mass of fission products upon mass of the parent nuclei क्या होगा? तो हमें पता है कि जब fission होगा तो sum of the mass will be converted into energy. So the total mass of the fission products will be less than that of the parent nuclei. So this thing will be less than 1. Okay. A nucleus ruptures into two nuclear parts which have their velocities in the ratio 2:1. What will be the ratio of the nuclear size? So radius का हमें निकालना है. So now any nuclear reaction, the momentum is conserved. So P1 will be equal to P2. So we can write that M1 V1 will be equal to M2 into V2. So M1 by M2 will become V2 upon V1. Okay. So M1 by M2 will become V2 upon V1. Here the velocities are in the ratio 2:1. So it will become 1 by 2. All right. So now mass को हम लिख सकते हैं volume into density. And densities of the nucleus will be same. So इसको V1 upon V2. Volume का ratio will be 1 by 2. And volume को लिख सकते हैं 4 by 3 pi r cube. So 4 by 3 pi r1 cube upon 4 by 3 pi r2 cube will be equal to 1 by 2. So from here we can say that r1 by r2 will become 1 by 2 to the power 1 by 3. All right. So this will be my answer. So again, रेडियस का कहीं ना कहीं इन्वॉल्वमेंट है. मास, वॉल्यूम, डेंसिटी, रेडियस, व्हाटएवर, आपको ये ध्यान रखना है. एंड हर न्यूक्लियर रिएक्शन में द मोमेंटम विल बी कंजर्व्ड, लीनियर मोमेंटम विल बी कंजर्व्ड. ऑलराइट. The mass of proton is 1.0073 units and the that of neutron is 1.0087 units, where U is AMU. The binding energy of 4 point sorry, the helium is. So we know that binding energy जो होती है वो डेल्टा एम इंटू सी स्क्वायर होती है, और 931.5 इंटू डेल्टा एम इन ए एम यू ये मेगा इलेक्ट्रॉन वोल्ट्स में होती है. तो दैट्स व्हाट वी हैव टू फाइंड द डेल्टा एम. सो डेल्टा एम विल बी मास ऑफ न्यूक्लियॉन्स माइनस मास ऑफ न्यूक्लियस माइनस मास ऑफ न्यूक्लियस. ये इंपॉर्टेंट है बहुत क्वेश्चन, एज इट इज क्वेश्चन आपसे पूछा जा सकता है. ऑलराइट. सो how many protons will be there? There will be two protons, right? And how many neutrons? Two neutrons. So 2 into mass of proton is 1.0073 plus 2 into mass of neutron is given as 1.0087. All right. Minus 4.0015. Now, if we solve this, we'll get 0.0305. So it will be 0.0305 AMU or unit U, and the binding energy is 931.5 into 0.0305. And if we solve this, we'll get 28.4 mega electron volt. So these questions are a bit calculative. आपको पॉइंट्स में ऐड सब्ट्रैक्ट मल्टीप्लाई करना होता है, बट दे आर वेरी सिंपल. दिस फॉर्मूला विल बी यूज्ड. बेसिकली दिस वन, डेल्टा एम आपको निकालना है। डेल्टा एम हमें पता है मास ऑफ न्यूक्लियॉन्स माइनस मास ऑफ न्यूक्लियस होगा। ऑलराइट, नेक्स्ट क्वेश्चन, व्हेन टू न्यूक्लियाई with A is equal to 8 join to form a heavier nucleus, the binding energy per nucleon of the heavier nuclei. So जब तक देखिए हमें पता है बाइंडिंग एनर्जी पर न्यूक्लियन का जो कर्व होता है वो ऐसा होता है। So for the lighter nuclei, when they will combine, so the binding energy per nucleon of the heavier nuclei that is formed will be larger. ठीक है, तो binding energy more than the binding energy per nucleon of the lighter nuclei. So this is our answer. The case when heavy nuclei is there, तो वहां पे रिवर्स हो जाएगा। ऑलराइट, वहां पर जब एक हैवी न्यूक्लियाई टूटेगा तो जो लाइटर न्यूक्लियाई बनेगा उसका बाइंडिंग एनर्जी पर न्यूक्लियन ज्यादा होगा। The binding energies per nucleon for a deuteron and an alpha particle are x1 and x2. The energy released in the reaction है। So the energy released in the reaction जो फॉर्मूला होता है हमारा, वो आपको ध्यान रखना है, इट इज द बाइंडिंग एनर्जी ऑफ प्रोडक्ट्स minus the binding energy of reactants. So this is what you have to remember. The Q value or the energy released in the reaction. So here the Q will become how much? Binding energy of the products. The binding energy of the products is how much? The for the alpha particle, it is given as x2. So it will become 4x2 per nucleon. It is given. So I am multiplying it with 4 minus of 2 into 2x1. All right. So this comes out to be 4 into x2 minus x1. This will be my answer. So ये फॉर्मूला आपको यूज करना है, दिस इज द गवर्निंग फॉर्मूला एंड पुट द वैल्यूज व्हाट एवर आर गिवन। द बाइंडिंग एनर्जी पर न्यूक्लियन दिया हुआ है, so we have 4 nucleons over here and 2 nucleons over here. Energy released in the nuclear fission, energy released in the nuclear fission is due to the heavy nuclei is getting splitted into the fragments. The fragments will have the higher binding energy per nucleon. We discussed in the one of the previous questions as well. Therefore, the total binding energy of the fragments is more than that of the parent nuclei, and this excess binding energy we get in the form of kinetic energy. All right. So, the binding energy of the fragments is more than the binding energy of the parent element. All right. Next question. Which of the following is used as a moderator in nuclear reactor? So it's a heavy water. It's very important. You have to remember. You have to uh, revise this nuclear reactor thing. All the things that are used. Cadmium rods किस लिए use होता है? Heavy water किस लिए use होता है? So it will be definitely asked in the exam. So this was all about these chapters. Not a very large number of questions are formed. Very less number of questions are there, but you have to practice them. You have to be confident. Once you have solved the entire NCRT, you should feel confident कि जो भी question आएगा वो देखा हुआ आएगा. So this is about the chapters. Now let's meet in the next master class, and it will be a combined class, right? And let's solve the multiple questions from different chapters, and we'll try that many of the questions or concepts are repeated in the actual exam. So thank you very much. All the best.